And then we move to the third speaker, okay, from Meizhou University. This is also very big agriculture university in Thailand. Yeah, we have one of the distinguished speakers, Professor Sai Yu. Yeah, Sai Yu. Okay, the floor is yours.
Thank you for Professor Xu, and good afternoon, ladies and gentlemen. Again, I'm Assistant Professor Dr. Japaniransin. You can call me Ajahn Sai Yu. Sawadee ka. I'm from Thailand Major University, and thank you for honoring me to give a speech about the waste to energy success case in Thailand, both of industrial and community part. This is my experience, research, and my collab with about entrepreneur in Thailand, and to build about the trainer in community in northern Thailand. Yes, and I'm the program chair of the Master of Engineering in Renewable Energy Engineering Major University, and we also exchange about the student in Fengjie University. And this is the first time to come to Taiwan. I was very impressed to know about the beautiful university here. Okay, for Thailand, for about the food processing industrial that's growing up in most for about food waste. This is a major problem in Thailand now. Number one of the type of the waste is the food waste, from the kitchen waste, from the restaurant. Then biogas is coming answer. It's a technology to solve this problem. Why? If someone in the room come from other field, I use a few minutes to explain. Biogas is the technology that converts about waste to energy. We are about the chemical reaction, like that you put the food in your body, digest, and then put about the energy. So the consist of the composition of the biogas is a major component is methane. This is around 50 to 70%. This is a major component that give about heating value. And then we can use about biogas instead of electricity, instead of LPG, or fuel in the industrial part. So when we discuss on about the chemical reaction, we have 3 states or 4 states in biogas production. First, the substrate that put into the biochemical reaction in the biogas production, there's carbohydrate or protein or lipid. This is the component of the waste from the industrial and in about the food waste in the community. And then the hydrolysis is the first process that give about a small molecule of carbohydrate that we call monosaccharide or glucose, and protein give about amino acid, and lipid, this long chain fatty acid, and then convert into the powder substrate to convert to methanogenesis into the last process that we call acetic acid, CH3TOOH. And then we get about the methane with about the methanogenesis in the last process. Maybe that sometimes we can get about the acetic acid. Life is not perfect. So we have repeat about the process again, and we can get 4 steps in biogas. So we can convert about the organic matter in the waste into the energy in the last process that we call biogas. And it consists of 3 that I have told you: methane, carbon dioxide, and other gases, including about the hydrogen sulfide too. So for about biogas industrial scale, for my highlight experience work, focus on about the collab with about the Sunsweet Public Company Limited in Chiang Mai and in northern Thai. He is a major corn can processing in Thailand. they have wastewater and solid waste in the corn process. They provide the product into all the world, all the country in the world. So when they manage about the solid waste, they sell the solid waste from corn waste, corn cobs, corn husks, and corn seed to farmer. Each one day, they have 100 tons per day. They sell 300 baht Thailand per ton. They get the value from the waste, 300,000 baht. But the CEO of Sunsweet Public Company Limited said and told me, Professor, no, I would like to get about the sustainable management to manage about the solid waste per each day. So we try to do about experiment and do the research with about solid fermentation, investigate and study about the potential of the corn cobs, corn husks, corn seeds in the biogas system. Why? Because of almost in 90% in Thailand, 95% in Thailand, biogas also wet fermentation from wastewater from farm. For about the solid waste, it's difficult. It's too difficult to control. And when you ferment in dry fermentation, in the last, after you get about the energy from the system, you also get about the solid. So we investigate and study, and we get the percent methane of about biogas production from this system for 64%. It's too high from about the biogas fermentation from dye. And it leads to about the CSTR system in the Sunsweet company. This is around 7,000 cubic. In one day, we put about around 40 to 50 tons of corn waste into the system. We get around 10,000 cubes of biogas. And all of this we put into the generator to convert into the electricity. And we get around 18 to 20 megawatt per day. This is the prototype in Thailand. I think that 3 companies have dry fermentation in Thailand. And for others, entrepreneurs that we get about the problem to solve. There's a miso. Do you know miso? Miso is Japanese, one soup of Japanese. They always wash rice, bean, and boiled bean wastewater. The major problem is boiled bean wastewater. The COD value is around 50 to 70 milligram per liter. So, 50,000 to 70,000 milligram per liter. This is a major problem. And then we try to investigate that. How about the potential of boiled bean water from the process? We created about the BMP, or biomethane potential, to investigate the characteristic of the wastewater. And then we create a modified cover lagoon. The sizing of this plant is 50 kilo. This is more. First, we worry that the gas can put about the HDPE because it's too thickness. But the potential of boiled bean is very good. We can get the gas every day. And this is the prototype of the miso. Because wastewater in Thailand is not the same. It depends on the characteristic of the substrate and the process of food processing of each company. And we said, wow, when we measure about the methane at the miso reactor plant, we get the methane percent 74%. This is very high, but something happened. This is very high too. This is hydrogen sulfide. And the last highlight success case that I would like to show in this conference is the biogas production from wastewater of trade pork processing. In Taiwan, pork is not favorite, right? Like about the chicken. So in Thailand, pork is favorite food for the people. And trade pork is like the meat processing with about sweet tasty. And we get the wastewater, they cover with the grease around at 3 centimeters or 4 centimeters. We investigate the potential of this wastewater. We are about the biochemical methane potential. That I have told you, the wastewater is not the same. It depends on about the substrate and process. So we know about the potential of this wastewater. We get about the high percent of methane content is around 64%. The highest is 68, sorry. Why we do this? Because this is lead to about I think that is a way to research about the growing of food processing industrial in the future, in the northern time. And for about the biogas reactor in community scale, for last 15 years, I start to create a project to provide a technology into the community. This is small scale, right? For solve the problem, food waste in the community. I start with the 1 cubic, but for in this figure, we have 2 cubic. To solve the problem of the food waste and kitchen waste in community, to reserve about noodle shop, restaurant, homestay, resort, hotel in the community and in the school. We try to create about the reactor from polyethylene. This is a second-hand polyethylene. This about the take chemical to Thailand. We wash and then we create to put about the stir into the tank to stimulate about the chemical reaction. We start with about the cow manure mixed with the water, and we leave for 7 days, and then we put the food waste into the reactor. The cow manure will digest the food waste and give about the biogas. And we use about the water replacement to instead of the gas holder, and then pour it into the fire. Yes, this is our inoculum. We use cow manure. We can use dry or fresh cow manure mixed with the water. It looks easy, but this from the research. We use the time to study the characteristic of this inoculum. We use 3 years, and we currently is not die. This not in for this inoculum is not die. Yes, when you always put about the water, the wastewater or the food waste into the reactor, and we leave the agent for 7 days for startup, and then we put about food waste into the tank, and we give about biogas. This is one method to stimulate about the biogas chemical reaction with about the cleaning, like that you eat the food. If you always, your stomach is very good too, same as the biogas production. So we always create about the reactor with about the people in the community, and I think I teach the people in the community. I must teach the youth in the community too, the children in the school. The children know about the useful, the advantage of about the biogas technology. The parents know, they help together. So in our community near university, near my university, I teach the student in the school, and then I ask for the fundamental to my university to give about the training into the people. The first year, I teach 12 village for create prototype. How to teach? In the morning, 3 hours, I teach about the theory, about the story. And in the afternoon, I practice. If you know how to build the tank, you can correct in the future if some problem happen with about the using. And from this project, we get about 30 communities, but we have COVID, right? Do you remember COVID? Yes, but I get fundamental already. So I try to solve the problem with change the fundamental to record and to create the video via YouTube. In the morning, I teach you on site. For COVID situation, I teach you online. Look like a television program. You can learn via the live program at your home. And you come to practice only 1 or 2 hours. This is our chance from COVID situation. And we get about the chance to work with Department of Military Energy for the soil. Around 76 provinces in Thailand to create about a reactor to solve the problem of the food waste in the military unit in each province. But this is I use complex. This is not a good, but it is an initial part that we start. Okay, and this is me in the past when I start to do the biogas. I start from the user, not builder. I use the biogas and then I would like to get more biogas. I would like to solve the problem from the system. This is a system for 20 units and give the biogas into the 2 buildings of the soil. Okay, and we get the chance to collaborate with about the community to create the appropriate menu or recipe that use about the proposed heating value with about biogas technology. Because of heating value of biogas is half of LPG. Yes, and for our prototype, it lead to the only one project in Thailand for 3 years to get about the fundamental from the Ministry of Higher Education, Thailand, to get the fundamental, how to trainer in the community. For me, not over 20 years, I will retire. I can't go to train everywhere in Thailand and in Northern Thailand. So I think I should train the trainer in the community to help me to train about the biogas technology. How to? First, you train with about biogas technology, same as the last project. But when you see about the technology already, 1 month, you will teach to learn. You will learn about how to post in TikTok, how to post in Facebook, how to create the project via my project. So after project finish, you can be TikToker to post about the story of biogas, to show how to cook by biogas, how to build biogas. So we get about 100 trainers from this project for 3 years. And this is a fundamental from Ministry of Higher Education. Yes, this is the example of the project, the product of the project. This TikToker from the trainer. Who are the trainer? Merchant, housekeeper, everyone in community. Yes. And from the project, we get about the trainer who are farmer, who are the merchant, who are the man who sells about the noodle shop. He is 74 years old, but he can't be trainer of biogas. This is my ideology, to give the chance to the people in the community. Yes, and we have the prototype from this project. We have the prototype of food waste management for homestay on highland with biogas technology, because we think that for about the restaurant and about the homestay, they always have a lot of food waste. Prototype is very significant in Thailand to give the chance to others. This entrepreneur, he is architect, and he decides about the plant with a plastic bottle. So this is my experience works and my success case in Thailand that I have told you. In COVID situation, we have the chance to get about YouTube with Biogas Easy. And this is one way to communicate about the story of biogas in Thailand. I'm so sorry that in Thai version. Yeah, this is my success case in Thailand. Thank you very much.
Thank you for Dr. Sayu. Yes, so any question? Yeah, this is Professor Xie, Cindy Xie. Yeah. Okay, that one.
Thank you, Professor. Really, really amazing, because this is what I really hope to do in the future. I got a question about sustainability. So everything we do, we want it to be sustainable. It's really amazing that you gave a lot of children, okay, high school or community education, okay, workshop, and you even have some trainers. But how can you make sure that after the training, after all the practice in the workshop, they can be put everything in practice in a sustainable way in their households and in their community? For example, like in Germany, there is like a top-down system, okay? The government has the policy, so like everyone has to do it. So may we know more about the policy in your country so that it can be certain that everything is done in a sustainable way? Okay, thank you.
Thank you for your question. From our practice, from our training, the first step, we teach about the theory in the morning. In the afternoon, we practice how to create or how to build about the reactor. And then we will teach how to correct about the problem. When we get the problem from using, and when we get about the biogas from the system in the first time, and then we follow about the using of the training. And we count about the project. We follow about the project. We count about the project that can get from the community that we train. Yes. And we have YouTube to help, always help how to create or how to correct about the problem when you use in the long term. But now this project, this around 8 to 9 years still to be prototype in the community, around 70%. 30% lost. This normally, I know. But we get about the prototype that can communicate with about the social. We are about the noodle shop. We are about the center of the village, the leader of the village. Yes. For in Thailand, we have Kok Nong Na model. This is a prototype in Thailand or country. They use this model to solve the problem. So that you ask that how about the sustainable? Surely this is a big problem. Biogas always happen the problem with about the management. Yes.
So any other question from the floor? No? Then, thank you for Professor Sayu, for this very fantastic presentation.